So hi, in this problem, we're going to solve the problem regarding probability which appear in J Advanced 2020. Now, first try to understand the problem statement. Here we have two coins and they are biased. C1 and C2. What's the meaning of biased? Biased means that there is some discrepancy there in the coin C1 and C2 such that the probability will not be exactly equal to 1 by 2. That's why it's called biased. Okay, so it says that if the coin toss C1 toss, then the probability of getting hit is 2 by 3. In the second case, it's 1 by 3. Now it says alpha is the number of head and beta is also number of head when both the costs tossed twice, and getting the probability in these events are independent event because it's mentioned. So the probability of getting head in C1 doesn't affect the probability on C2, as well as getting head for the first toss doesn't affect in the second toss, right? Whenever we toss the coin second time. So they are doesn't connected. So that's why they called independent. Now we need to find out the probability that root of the given quadratic equation are real and equal. And that's it. So let's go ahead and solve this particular problem. So first, it says that what is alpha and beta. So we can say that here, we can simplify the problem as alpha comma beta be the number of heads, be the number of heads while C1 and C2, both the coin actually, C1 and C2 tossed twice. So therefore, right, as alpha and beta are number of heads and we are allowed to toss twice. So what is the possible values of alpha? Possible values of alpha will be 0, 1, and 2. And same thing happens for beta because 0, 1, and 2. Why? Because when the two coin is tossed or a coin tossed twice, right? What is the possibilities? We get either no head, 0 head, 1 head, and 2 head. That's it. Now, our job is to find out the probability of these events separately. That we go ahead. So here it says that for the coin C, the probability of getting head is 2 by 3. So therefore, the probability of getting tail in this particular problem will be 1 by 3. That's for sure. Now we're trying to calculate probability of alpha is equal to 0. That means that, right, probability of alpha equal to 0, not probability of alpha equal to 0. Both are different, right? So alpha equal to 0. That means we are trying to find out the probability of getting 0 head and 2 tail. 0 head means that we'll get 0 head and 2 tail. So therefore, right, it is equivalent to getting 2 tail. So therefore, it is 1 by 3 whole square and therefore it is 1 by 9. Now we try to find out the probability of alpha is equal to 1. So that means that we are getting probability of 1 head and 1 tail. Now, when it is 1 tail and 1 head, it is equivalent to probability of first we can get head and then we get tail. Or maybe someone get it as first is tail and then is head. So therefore, the probability will be, what is the probability of getting head? That is 2 by 3. We can use it as a multiplication format because they are given as they are independent. So therefore, it is 1 by 3 and 2 by 3, which gives us as 4 by 9. Now see that we use the concept that probability of getting head and tail is equal to probability of head multiplied by probability of tail because they are independent. And if they are not independent, so we should not apply this particular concept. Let's go ahead. So now we need to find probability of alpha is equal to 2. That means number of heads is 2. So probability of 2 head and 0 tail. Now probability of 2 head means that it is 2 by 3 whole to the power 2, that is 4 by 9. So all the event for C1 or the coin, when I toss the coin C1, that is obtained. Now for C2, we know probability of getting head is given as 1 by 3 and probability of getting tail is equal to therefore 2 by 3. It's a complement event. Now let's go ahead and find probability of beta equal to 0. That means number of head in this case is 0. So therefore we get 0 head and 2 tail. So therefore getting tail is 2 by 3. So 2 by 3 whole square, and that's why it's 4 by 9. Probability of getting beta is equal to 1. So that's implied here we get 1 head and 1 tail. Same logic, here we can get first head and then tail, or maybe some experiment we get first tail and then head. So therefore, it will be, what is the probability of head? Probability of head will be 1 by 3 multiplied by 2 by 3. Then 2 by 3 and 1 by 3, which gives me 4 divided by 9. And probability of the last case, beta is equal to 2. That is probability of getting 2 head and 0 tail. So therefore, it gives me as 2 head. Head probability is 1 by 3. So 1 by 3 whole square. That gives you 1 by 9. So with that, we are able to compute, right, all the probabilities in the respective cases. Let's go ahead. Notice we obtained all that probability. Now I have to find the condition or the possibilities or the probabilities so that the given quadratic equation have equal roots. So here we'll consider that let A be the event so that the quadratic equation x square minus alpha x plus beta are having real and equal roots. Now, what is the condition of having real and equal roots? That means that the discriminant of this particular equation are actually 0. What is the discriminant? B square minus 4ca. What is B here? Alpha square minus 4 times c. C here beta 1 is, or a is 1. So therefore, B square minus 4ca is equal to 0. That's imply that alpha square is equal to 4 beta. Okay, I told 0 but wrote 1. That's sorry, it should be 0. Okay, that's it. Now why? Because we know that if my quadratic equation is ax squared plus bx plus c is equal to 0, the discriminant of this equation is b squared minus 4ca. And for this particular problem, b is equal to minus a, c is equal to beta, and a is equal to 1. So using that, we get the condition to find out the discriminant. Okay, that's it. So now see that if alpha square is equal to 4 beta, then only we get, right, our equation will have equal real and equal roots. Now here we also know that alpha and beta are belongs to or takes only the values 0, 1 and 2. So therefore this condition is satisfied, right, only when alpha equal to 0 and beta equal to 0, both will be 0. Or the second condition is that it will be alpha is equal to 2 and beta is equal to 1. So therefore, the required probability of A can easily be written as probability of alpha 0, beta 0, plus probability of alpha 2 and beta 1. Now, as these events also are independent, so therefore it is probability of alpha equal to 0 probability of beta equal to 0 plus alpha 2 probability and probability of beta equal to 1. That's it. Now observe that we already calculated this event earlier. Alpha equal to 0, it's 1 by 9. Beta equal to 0, it's 4 by 9. Alpha equal to 2, it's 4 by 9. And beta equal to 1, that's also right, 4 by 9. So what happened? It is 4, 4, 16. 16 plus 4 is 20. 20 divided by 9, 9 at 81. And that's it. So therefore, for this problem, option B is the correct option. And that's it. Hope you understood this particular problem appear in advanced level. Thank you.
Like, comment, and subscribe. Like, comment, and subscribe.